Hello viewers, in this video we will see stepwise method in order to perform operations on signals or in order to sketch the signals, especially in terms of continuous type of time signal. So this is the problem example given. The signal is defined within the time interval from 0 to 4, where at time interval 2 it is having an amplitude of 10. Since it is given in terms of x of t and t, we call the signal as a CTS type of signal. So these are the problems which they have given, for which you have to perform the different operations and you have to sketch the resultant signals. First and foremost thing is, it is given in terms of x of minus 2t minus 4. So before going with the problem, let me just explain you one of the most important rule which you have to remember in order to solve these kind of problems. So when there is a mix of operation performed, if you see in a particular format of x of at plus b or x of say at minus b format, any of this format. So let me consider an example of x of at plus b type. So here if you see, I am having a shift operation in terms of x of t plus b. Then there is a at plus b, which is in terms of time scaling operation. So this is comprising of time shifting as well as time scaling operation. Suppose if I had an equation in terms of x of minus at plus b, after this I am having x of minus at plus b. So this minus, which is corresponding to the time with reference to the minus sign, for the time signal it is having, that is the time variable, it is having a minus signal. So this particular operation is called as a time reversal. Whenever you have a mix of these signals, we are going to make use of an important rule in signal which is called as a precedence rule. According to this precedence rule, when I am having a mix of all the operations to be performed in a single question, first and foremost thing is I will be performing a time shift operation, then we are supposed to perform time scaling operation, and then the time reversal and all. So we will keep this particular concept in mind and we will start to solve these problems. So first let us solve with the first problem of x of minus 2t minus 4. So in case of x of minus 2t minus 4, first I am having time shift. Then I have 2t minus 4, which is time scaling. Then I am having minus 2t minus 4, which is time reversal. So first we have to perform time shift, then time scale, and finally the time reversal operation according to the precedence rule. So let us start solving the problem example first in terms of time shift. So this is the method what we are going to follow. First we have to perform time shifting, that is in terms of x of t minus 4. I have x of t. So this is I want t minus 4, I have to substitute t as equal to t plus 4. Suppose if this was t plus 4, I have to substitute t value as equal to t minus 4. If the required signal is in terms of minus, I have to perform plus operation. If the required signal is plus, I have to perform minus operation, vice versa. So now I want x of t minus 4. So that's why I will substitute in the main signal given in terms of x of t. In that I will substitute t as equal to t plus 4. So if I substitute t as equal to t plus 4, this 0 becomes 0 plus 4, 2 becomes 2 plus 4, and 4 becomes 4 plus 4. So the signal will start from 4, 6 and end at 8. So that will be the plot for x of t minus 4. So I am getting a plot of x of t minus 4 with reference to the independent time variable t. So the signal is going to start from 4, this may be 6 and this may be 8. So at the shape of the signal won't change, only the time is going to change. So obviously when you are going to have the signal shifted from 0 towards 4, so the signal is something of this kind. So the amplitude will also remain same, that is equal to an amplitude of 10. So this will be the plot for x of t minus 4. Second is I have to perform time scaling operation. So let us perform time scaling operation next. So if I perform time scaling operation, so if you see the scaling value is equal to 2 in this case. So I have finished till here t minus 4. Next I have to perform scaling, that is x of 2t minus 4. So I have to get the signal of x of 2t minus 4. So in this case, to get x of 2t minus 4, so what I have to do is, so I am having t minus 4 signal here. So for this, the time scaling is 2t. If it is a multiplicative term, here 2 into t it is, not t by 2 division term. So if it is a multiplicative type of scaling with reference to the constant value and the time scale t, if it is multiplication, if you require multiplication type of signal, then the operation which you need to perform is division. If you want division type of signal, if this was t by 2, then I have to multiply the time scale by 2. Now I want 2t required is multiplicative term, so I have to divide the time scale of t minus 4, whatever the signal I have obtained, I have to divide that time scale by 2. So what I will do, I will divide this time scale by 2. So if I divide this by 2, this is 4 by 2, 6 by 2 and 8 by 2, which is 2, 3 and 4. So the signal what I am going to obtain for time scaling will be something like this. This is x of 2t minus 4 and this is time t. So the signal will start somewhere here, that is at 2. This will be 3 and here it will be 4. The amplitude will remain same. The amplitude will remain same and you are going to get the shape also same. This is 10 amplitude. So this will be the plot for x of 2t minus 4. But according to the question, I want x of minus 2t minus 4. So x of minus 2t minus 4 I require, which is nothing but a time reversal operation. So at the third step, I will perform time reversal operation for this particular signal of x of 2t minus 4. So perform time reversal operation in the third step. So I require x of minus 2t minus 4. So the same signal, but here I am having minus 2t, which means that I have to take the mirror image of this, or I have to substitute t value in this as equal to minus t. So 2 will become minus 2, 3 will become minus 3, 4 will become minus 4. So in such condition, I will be getting the plot for x of minus 2t minus 4 signal, x of 2t minus 4 signal as, let me just erase this. This is 2, 3 and 4. So I have to take the signal from the negative side now, mirror image. This is 0, this is minus 2, this will be minus 3 and this side it will be minus 4. The shape will remain same once again. So exactly at minus 3 it is having an amplitude of 10 and rest all it will remain same. So instead of 2 it is minus 2, instead of 3 it is minus 3, instead of 4 it is minus 4. So this is the required signal for x of minus 2t minus 4. So let us go with the second problem. Similarly, here it is in terms of plus sign. Here it was minus, here it is plus now. So I want the signal in terms of x of minus 3t plus 2. In this also there is a time shift operation and I am having 3t. So t is multiplied with some constant value, which is nothing but a time scaling operation. And finally, I am having a minus sign for 3t plus 2, which is called as a time reversal operation. Once again, if I apply the precedence rule, first I have to perform time shift, second time scale, and finally time reversal. So first let me start with time shifting. Time shifting, where I require x of t plus 2 signal. So x of t plus 2. So I told if you want the signal in terms of plus, you have to use minus in the operation. So instead of t plus 2, now I have to substitute t as equal to t minus 2. Here it was t minus 4, that's why I substituted t as t plus 4. Here it is t minus 2, that's why I am substituting t value as t minus 2. It is plus 2, so I am substituting it as minus 2. So my original signal, if I substitute minus 2, so this becomes 0 minus 2, 2 minus 2, 4 minus 2. So the signal will be something like this. So minus 2, 0 and 2 I want. So this is x of t plus 2 signal. So this is your time variable t, independent time variable t. This is minus 2, this is 0 and this is plus 2. So here I have to take a triangle once again, which is having an amplitude of 10. So this is my x of t plus 2 signal. But I want x of minus 3t plus 2. So second I have to perform time scaling operation, which is nothing but x of 3t plus 2. So second is time scaling. Time scaling, where you will perform the operation of x of 3t plus 2. It is again multiplicative term with reference to the time. So I have to divide in terms of performing the operation. So what I will do for this particular scale, where I am having minus 2, 0 and 2, I will be dividing it by 3. So this becomes minus 2 by 3, this becomes 0 by 3, this becomes 2 by 3. So in such condition, I am getting the sketch or the plot for x of 3t plus 2 as minus 2 by 3. So minus 2 by 3 may lie somewhere here. This I will take it as minus 2 by 3. This is 0. 0 by 3 is 0. And then somewhere here I will consider it as plus 2 by 3. So this is with respect to t. Again the amplitude will remain same. Amplitude will remain same, which is nothing but 10. This is x of 3t plus 2 signal. But I want x of minus 3t plus 2. So last case or last step I have to use is time reversal operation. So third one is time reversal, wherein I have to get the sketch for x of minus 3t plus 2. It is minus here. So I am just going to replace t by minus t in this particular plot. So what happens in such condition? Minus 2 by 3 will become minus of minus 2 by 3, which is plus 2 by 3. 0 is 0. This 2 by 3 will become minus 2 by 3. T value, just replace it with minus t. So again I will be getting the plot. So this will be 2 by 3, which will be towards the right side. This is t. So again the plot will be same, minus 2 by 3, 0 and 2 by 3. So this is the plot for the given equation in terms of x of minus 3t plus 2. Let's go with the third one. So third one we have it in terms of x of 2 into t minus 1. So this can be further manipulated as x of 2t minus 2. Here if you consider, I am having t minus 2, which is nothing but a time shift operation. Also I am having 2t minus 2, which is time scaling operation. So there is no time reversal here, minus sign is not there. So I need to perform according to precedence rule time shift first, then the time scale. So first perform time shift operation, time shifting operation, where you are going to consider the equation in terms of x of t minus 2. Here I am having t minus 2, so I have to replace t as t plus 2. So t plus 2 means in the original plot which they have provided you, if you substitute t as equal to t plus 2, this is 0 plus 2, this is 2 plus 2, and this is 4 plus 2. So it is 2, 4 and 6. So your plot will be something like this. So instead of 0, it will start from 2, then 2 place it is having 4, then at 4 it is having 4 plus 2, which is 6. So the shape will remain same again. So this is having an amplitude of 10. So this is the plot for x of t minus 2. Next, second step is time scaling operation. Second one is time scaling operation, where you want the equation in terms of x of 2t minus 2. X of 2t minus 2. Once again, t is multiplied with 2. So in the operation, I have to perform divided by 2. So instead of 2, it is 2 by 2. Instead of 4, it is 4 by 2. Instead of 6, it is 6 by 2. So I have to consider the sketch. Something in this manner. So this is x of 2t minus 2. This is t. 2 by 2 will be 1. 1 is somewhere here. 4 by 2 is 2. 2 will be exactly here. Then 6 by 2 is 3. It will be somewhere in the middle here. So exactly at 2 it is having an amplitude of 10. So this amplitude is equal to 10. So this is the end solution what you are going to obtain for x of 2t minus 2 or x of 2 into t minus 1. So fourth problem we will go with is x of 3t. So if you see here, a constant term is multiplied with t. So this type of operation we call it as time scaling. So this is inclusion of only one particular operation which is in terms of time scaling. So time is having some constant value prior to it. So it is multiplicative term now. So it is 3 into t multiplicative term. So in operation I have to use division. So for this particular signal I have to divide it by 3. 0 by 3, 2 by 3 and this is 4 by 3. So the plot will be, anyways time scale operation I have, so only time scaling can be performed. So this is 0 by 3 will be 0 itself. 2 by 3 may lie somewhere here. This I will consider it as 2 by 3, and 4 by 3 may lie somewhere here. This I will consider it as 4 by 3. So exactly at 2 by 3 you are having an amplitude of 10. So your plot will be something in this particular manner. So this amplitude will be 10. This is x of 3t with reference to t. Last it is 2 into x of t. Here if you see, constant term is not multiplied to t, but in turn it is multiplied with whole x of t. So this kind of operation we call it as amplitude scaling. Amplitude scaling, which means the amplitude is 10 now, it has to be scaled. So into 2, amplitude of x of t is 10 into 2. 2x of t I want, so it will be 20. So instead of 10, the amplitude will get changed to a value of 20. So here I will be getting a plot for 2x of t with reference to t. So this will remain same, 0, 2 and 4. So instead of 10 at time scale 2, it will be having an amplitude of 20. So this amplitude will be 20 in the final case because it is 2 into x of t. So hope this video was useful for all of you in order to understand how an operation is performed on a CTS type of a signal. Also how you can plot the sketch or how you can plot the signals in terms of CTS. So this is quite lengthier step what you are going to follow. So the same thing cannot be applied when you are going for any competitive exam. So in my next video I will be making a compressed video like how we can use a shortcut method or how you can use some tricks in order to solve these kind of problems. So this is what you are supposed to do the analysis in terms of university exam purpose. So for each and every individual steps they will be assigning some marks. So hope this video was useful for all of you. Thank you for watching.